So in the last video, you learned to add, subtract, and multiply complex numbers. But what about dividing complex numbers? So when we're dividing complex numbers, we're talking about problems like 5 over 4i or 3 over 2 minus 3i. Things like that. Basically, I have i's in the denominator. Now you may remember from geometry that someone somewhere decided we don't like having square roots in the denominator, and you had to do things like rationalize, where you would multiply by square root of 2 over square root of 2 in this case. If you don't remember that, that's fine. Nobody cares about that right now, but the point is that since I is the square root of -1, technically these two problems have a square root in the denominator, even though right now it doesn't really look like that. So we don't want to have I in the denominator, so what are we going to do? We're going to remember the fact that I squared equals -1. And so I'm going to use that fact to help me out in these problems. So my goal is going to be to get I squareds in the denominator, because then those will simplify to -1. So if I have a monomial in the denominator like this first problem, we're simply going to multiply by I over I. I can multiply by I over I because that's just a fancy form of saying 1. So that would give my numerator 5i over my denominator 5i squared, but we just said that I squared is equal to -1, so that means this is 5i over 4 times -1, which would give me 5i over -4. So now I've gotten my I out of the denominator and I'm happy. When we have something that is a binomial in the denominator, we're going to have to use something called the conjugate, okay? And the conjugate will come back in another unit for us. For now, what you need to know is that it does happy things with imaginary numbers. So if I have, in this case, 2 minus 3i, my conjugate is going to be 2 plus 3i. The number in front, or the sign in front of your I term, is going to change. So for example, if I had -4 plus 5i, my conjugate would be -4 minus 5i. I'm not just changing the sign. When I change the sign, it's called the conjugate. So we're going to use that because, like I said, happy things happen when I use the conjugate. You'll see what happy thing that is. I'm also showing like every single little step in this video. As you get better at these problems, you don't need to show every little step of simplification. That's fine. So I'm going to multiply by the conjugate. I'm going to change the sign in the middle, which we already said is going to be plus, and I'm multiplying by 2 plus 3i over 2 plus 3i because that's just a very fancy way to say I'm multiplying by 1, which is totally legal in math land. So we have 3 times 2 plus 3i in the numerator, and then I'm going to multiply 2 minus 3i, 2 plus 3i in the denominator. So I'm going to come over here, of course, use the box. So I have 4, -6i, +6i, and -9i squared. Well, what happens with those middle terms? Guess what? They cancel, because essentially what we did is write a factored form of a difference of squares. Well, what is I squared equal to? I squared is equal to -1, so I'm just going to cross that out, and that's going to make this 4 plus 9. So my denominator is going to be 13. So all that mess simplified down to 13 just by multiplying by the conjugate. And I'm going to distribute my numerator 6 plus 9i. And the last thing is, I like to have things in a plus bi form, which means I'm going to split up this fraction. 6 over 13 plus 9 over 13i. Now, let's look at one more problem. say I have 1 minus 4i over 2 plus 5i. All right, so I don't like having i's in the denominator, so I'm going to multiply by the conjugate. The conjugate of the denominator is 2 minus 5i. 2 minus 5i. So the difference with this problem is I now have a binomial times a binomial in the numerator, so 1 minus 4i times 2 minus 5i, and I have a binomial times a binomial in the denominator, 2 plus 5i, 2 minus 5i. I'm going to multiply all this stuff out. Then I'm going to replace everything with an I squared with negative 1. So once I simplify down, I get negative 18 minus 13i over 29, and we're going to split up that fraction. Now, neither of these two problems have had anything to simplify, but you always want to check if those fractions, once you split them up, can simplify a little bit. Done.